Hey, hello, welcome to the show. It is me, John Park, and it is time for JP's product pick of the week. First thing I need to do is actually just take care of a little business on the side here because I'm not sure that we got our product pick price set down yet to the special pricing that we're going to have. So bear with me just for a moment behind the scenes here and to see if I can get things worked out here. Let's see. Exciting show, I know, but I've got to check my internal communications stuff to see if something went haywire. Or that I'm somehow doing the wrong product pick. That could be a possibility too. Meanwhile, talk amongst yourselves. We've got people over in our chats, over in our YouTube chat. Hello to Dave Odessa, KC, Felipe Goncalves, Justin Kovacic, Tyrone Mix, Quinman16. Hello everyone. And if you are looking for the other chat, that's over on our Discord, which is adafruit.it/Discord. Head on over there and look for the live broadcast chat channel. That's where things are happening. And hold on one second. I'm going to let my Slack and my Basecamp load here so that I can chat with the new products team to make sure we get everything set. All right. In Basecamp, I'm going to check and see that I'm doing the right product pick. If we didn't get our wires crossed on dates, let's see. Yeah, today's the 21st. That looks good. All right, we'll see if someone can take care of that before we get to the big reveal. So what's happening here? This is the product pick show. I've picked a product. We are going to take a look at it, take a look at some of the stats and specs as well as a live demo. And I am hopefully going to have a discounted price for you during the show. We'll see if that gets taken care of. If not, enjoy a product demo and buy it at the regular price. But hopefully we'll be able to get that to the discounted price. So first of all, I'll let you know if you want to go and check it out, even before it gets set down. We've got the URL and the QR code right there, and you can check out usually this video inside of the product page. I don't think it's going to be displayed yet because this one got passed over here today. So keep watching here, however you're watching, YouTube, Facebook, LinkedIn, wherever it is. But on the side, go check out the product page, which is right there. It's product 6109. And to stall a little bit, I'll field some questions. I saw a question by Dave Odessa. What's in the yellow box on the workbench, JP? It was this week's product pick and some related stuff because I was building a demo. So sometimes I stick some related things in the little box so that I can carry that between the workbench here in the workshop and my little solder station inside in the studio. So there's some, I'll give you a clue, there's some little tiny heat sinks in there still and a couple of bags, and that's about it. The rest of it got used for the demo. And let's see, any other questions? And then I'll see if I can check in again with the team. Hello to, here's the Discord, by the way. Let me bring that up. Hello to Liz, hey, Blitz City DIY, Thin Man, Sam J. Ohio, C. Grover, hello, Some Nice, Paul Cutler, Jim Hendricks, Hendrickson, I should say. Thank you for popping in. And Liz, if you're watching, maybe you can ping some people too and see if we can get the discount price set. That would be over in the new products team. I checked over on the Slack there. It doesn't look like anyone's around. Or maybe ping Angelica or Travis or Lady Ada directly and see if someone can do that. I should probably find out how that's done, but I don't know if I have the right access levels to do the discounted pricing on things. All right, so I'll continue to stall, and then we'll check back in again in a moment. So the next thing I like to do, as is custom on here, is give you a little... Oh, that's okay, Liz. I don't have access either. It's all right. They don't want us just go changing prices willy-nilly. Thank you. Yeah, thanks for checking. See if you can ping anyone. I'm not sure where everyone went. It's too quiet. What I like to do before I go any further is jump back to the new segment from the Ask an Engineer when Lady Ada revealed this product. So take it away, Lady Ada.
Ta-da! It's a spinning motor connected to a motor driver chip. So we've had motor drivers before that were just like plain H bridges, but some people asked us to carry stepper motor driver chips. So these are specifically designed for bipolar steppers. They make it really easy because they do the micro-stepping support for you, and some of them even have like, debug signaling or UART control. This one is the first one. It's kind of the most popular and simplest. It's called the Allegro A4988. It can drive up to 2 amps of current into 8 volt to 35 volt bipolar DC motor. And you can get like little breakout boards from Pololu. They make these little tiny breakout boards that are used in a lot of 3D printers and CNC machines. That they just plug in and you could replace them when they get damaged or they blow. But I thought, and I don't want to make that exact thing because like that exists. So I thought you can get A4988 breakouts for super cheap anywhere. I wanted to make a really good breakout that's easy for people to use, that has like labeled pins and terminal blocks and a really easy to use potentiometer and LEDs to help you know what's going on, mounting holes. So it's like bigger than those little breakouts, but I think it's better because it's got, it makes it easier for you to get started on the off chance that you're trying to build something new, not just using an existing like 3D printer.
Yeah,
PC.
You might not blow something up because you have more understanding and control.
Yeah, and you can put like a heatsink on. It doesn't come with a heatsink, but I'm just showing here's how you would do a heatsink if you wanted to. It's 2-ounce copper, so it's designed for a good amount of current draw, and then we put electrolytic capacitor on there, just kind of help smooth out the motor power. One thing that I thought was neat, which you can't see in the demo quite well, but I can see on the overhead, is I added debug state LEDs, which I thought was useful. So the direction is either red or green, so as it spins forward or back, the LED tells you that it's getting signal, and then you can kind of barely see it, but this has a yellow LED that also pulses whenever you do a step. So this stepper driver can do 1, 4, 8, or 16 microsteps per step using the MS pins. By default, it's 16 microsteps, so you can see it's going kind of slow. But if I want, on the fly, you can change the microsteps either by connecting the MS pins to GPIO, or in this case, I just connected up, and now you're seeing it's flying. It's going really fast because it's now doing 1 step per step, or 1/4 microstep instead of 1/16. So if you want it to go fast, you use the less precise but bigger steps, and then if you want precision, you go down to the 1/16 microsteps, and you can do like very precision motion. So this is what people use for their CNCs and 3D printers when you want to move quickly somewhere. You do big steps, and then when you actually want to do the little cuts or the extrusion, you use the small steps. So it's ready to go, and I like the terminal blocks. You just plug in your wires, and then you have your motor power, and then your DC control here. So you can have a bunch of them. Very easy to use. And then, you want more current, just twist this pot with any flathead screwdriver.
Yes, indeed it is. And one second, we've got product Travis over on the product team fixing things in the background, so we should be able to get the discount code. I'm just going to chat with him for a second. Actually, I'm just going to refresh my page. I think maybe he's already taken care of it all. Getting there. We have progress, I think, happening. I will jump ahead actually to a question I saw over in the chat that people were taking care of. So Zoe Sherry asked about, does the stepper motor driver have an upper limit on how powerful of a motor it can drive? And Tyeth wrote a very nice answer. Says at the end of the product, it does. At the end of the product page description, suggests 2 amps maximum per winding and channel. If you go that high, then the heat sink will help, and a larger motor will be restricted to 2 amps. And as Lady Ada mentioned, we have a potentiometer on there to limit that. So the upper limit is 2 amps. You can lower that if you want to restrict it, restrict what you can drive on there, particularly if it's getting hot, if you don't have a heat sink on there. Let's see. Still, it isn't updating, so something's going goofy on there before I head over to the product page. Let me... oh, good, okay. Let's see. Travis is seeing it at the new price. All right, you tell me. I'll let you guys check it out, because it could be that I'm just not getting it refreshed through the various Cloudflares and caches as quickly here on the West Coast. That right there is the URL. Head over there. Let me know. Do you see a half price, a 50% off price, and a YouTube link in there? I bet you do, because I trust Travis, but mine is not refreshing. Any moment now, I'm expecting to see the glorious price drop on that. Either that or we're talking about different products. Hope not. What say you, chat? Have you seen the... no, not yet. All right. No discounted price yet in a... discounted yet in a private tab. Says, okay, so I think I've had some slow, goofy internet today. Maybe it's a generalized, a larger generalized issue. Paul Cutler says, the poor servers as everyone's refreshing at the same time. Bzz. It's okay, we can wait this out, right? We won't give up. You know what I'm going to do in the meantime is let me get going on showing this thing off. Maybe at the end we'll get the good price. So let's switch to that. Right there is my product pick of the week this week. It is the A4988 stepper motor driver. This has micro stepping. This is a proper stepper motor driver. It takes care of everything in one chip. Lets you drive your standard stepper motors, and it allows you to drive them in 2 directions. It is for bipolar steppers, which you usually see have 4 wires coming out of them. I have an example one hooked up that I'll show you. But let's jump first of all to the product page, which is right here, as I've mentioned. 6109 is the product ID. I'll refresh that one more time there. I'll refresh it again later. It hasn't dropped yet. So as you can see here, this is a stepper motor driver. These are used for steppers that you find in things like CNC machines, 3D printers, drawing bots, little robots, that kind of thing. Stepper motors allow you to get very precise positioning, unlike a DC motor that just sort of spins freely when you apply power to it. This allows you to energize a sequence of coils in a sort of clever fashion to turn a very precise step or amount. Usually we have, what is it? I think a 200 step per motor is a pretty typical kind if you're using full steps, but we can use micro stepping to go smaller increments, all the way down to 1/16 of a step increments, which I'll show off on here, being able to send these at different increments. And what else have we got? There are on here, we have the screw terminal so that you can screw in your bipolar motor wires, the four wires, as well as power and ground. So that's going to be an external power supply. Depending on the motor you've got, it can be anywhere from 8 to, I think, 35 volts DC. I'm using a 12-volt motor here that I'll show you in my demo. And we've got on here a couple other conveniences. Hey, look, the price just updated. Thank you so much, Travis, as well as maybe the internet for waking up there. I'm sure it was a caching thing. So you can see the indicator both for steps. There's a little yellow LED on there that will flash every time we send it a step pulse, as well as a direction LED pair. We have a red and a green LED, and those will light up depending on which direction we're sending as we reverse the motor forward and backward. And what else? You control it with just 2 pins on your microcontroller for the most basic function, which is simply sending the thing in whatever step mode you have selected with the micro-stepping pins on here. There's 3 pins that you can set high, 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 low, low, high, low, high, and so on, to pick anywhere from whole steps, 1, half steps, quarter steps, 1/8 steps, or 1/16 steps. You can also use 3 pins on your microcontroller to do those, which is what I'm going to show you in the demo. So rather than jumpering them, you can send high or low a GPIO pin and pick the different stepping setups. So let's go and take a look at this view of the world right here. Oh, 1 second. I think we had a, yeah, we had a. Okay, so let's take a look at what's going on in here. I've got my QT Py RP2040 is what I'm using here, running CircuitPython. And you can see I actually have 5 wires running from it for GPIO. So I'm doing the direction and step, which is the most basic method that I told you about. Then I'm also using these MS1, 2, and 3 pins to set the micro-stepping size. So in the code here, you can see I'm not using any particular fancy driver. It's just digital I/O. I have a couple of pins here for direction and step. I have 3 pins selected here also as outputs for the different micro-stepping configurations. And then I have a little function here called set microstep mode. This allows me to just set these little 3-pin clusters so that when I'm in full step mode, I set those pins, all 3 of them low. When I'm in 16th step mode, I set all 3 of those pins high, and then the different variations in the middle there. This makes it easier for me to demo this right here. And you can see right now I'm set to micro steps. So I'm going 16 steps per step, essentially. So it's taking about 3,000 little micro steps to get around 360 degrees. And as Lady Ada mentioned, this is useful for when you're doing really precise things like setting down your hot plastic on your 3D printer versus when you're moving around to new positions on the printer bed, then you would move up to a faster mode. So let's take a look here. If you look, I've got a little NEMA 17 12-volt stepper motor. These are ones that we sell in the store. I printed a little, what do you call these things? Spindle for it? Not a spindle. I don't know what you call these. Just print a little end on there that you can use to gear up a little chain motor like you find on a set of blinds, that kind of thing. Can use like dog tag chain style belt for it. And I also printed a little part of it, just this little pink bit that you can see moving back and forth just as an indicator. So right now this is moving as fast as it can, basically at the 16th steps, which means pretty slow. I'm going to move this up to the fastest right here. So this is 1 micromode. So this is whole steps. It'll only take 200 steps to get around the 360 degrees, much, much faster. Check it out. This is when things are zipping around. Whip, 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 whoop. And it's actually pretty quiet. We have another driver that came out recently that's even quieter, but this one I'm not hearing much, and this is not shock absorbed or anything. I've actually got it sit on a piece of wood here, and I'm really not hearing much come out of it, which is pretty nice. And as you can see here, we're in mode 1. It just prints when I switch directions. If I move up to, let's say, mode 2, this should take twice as long. Whoop, whoop. Now, this is not using any sort of optical encoder or anything like that to know where it is. It just is very good at precisely going the number of steps you give it. These are often paired up with encoders to do more precision things. But you'll notice it's going to leave and return to the same spot every time wherever I start that from. If I move this up to quarter step mode, I'll wait till it stops right there. Okay, it's going to maintain that position again, back and forth, except now it is a little more precise because it's taking 4 times the number of steps than the whole steps. And then we can go up to 8, even slower and more precise, and then back to our 16 that I had at the beginning. Start it from there. So you'll see it'll run the full 360 wherever we started from. So yeah, Tyeth Gunnery, is this a gear for window blinds? It is. That's exactly what it's for like a beaded chain. And it was just something I found on one of the 3D hosting sites. I was just looking for something for that shaft, and it looked good, and I just added a little indicator there. You will often find these will have there's a GT2 belt pulley on there sometimes. Pulley is the name this usually goes by the way. And those are good for like those rubberized belts that we use in our camera slider projects that the Ruiz brothers have done. So this is a good driver for that kind of thing. If you want to do little motion controlled camera sliders, those sorts of things, it doesn't have to be XY or X, Y, and Z. You don't have to get complicated. You can just move things on a single axis with one motor and get some nice results. Let's see. So one interesting thing here, I'll show you if we uncomment this. I'm now printing, if you see at the bottom there, the number of steps. It's going to slow it down just because I'm sending prints as well. But here are 2,900, 3,215. So that's the number of micro steps at 16 that it's going to do. If I drop this back down to 1 and print, you'll see we're just going to go 0 to 200, 0 to 200, 0 to 200, whipping around really nice and fast. Let's see, other questions? No, good. All right. Yeah, so that is it. It is actually really straightforward to run, and maybe we could do a library that encompasses some of this stuff, but I can post this code if anyone's interested in just having a little way to set your micro steps from GPIO. That makes it pretty easy. You will see here I've put compared to, let me go to a full screen here. Let me make myself a little smaller. There we go. Yeah, you will see here, this is the board as it comes. I've just added a small little heat sink onto the driver chip there just to help dissipate some heat from there in case you start drawing a lot of current. This one shouldn't be drawing too much until we sort of add some resistance to it there. The thing that gets hot really is the motors itself. These things get very hot. All right, so let's see what else. Yeah, if you head back here to the product page, you can see we've got that set at half price, $3.48. That'll be good during the show. You don't need a coupon code or anything like that. You will see that on the product page there is a link to the motor that I'm using right here, the stepper motor NEMA 17 size, 200 steps, 12 volt, 350 milliamps is what it's rated to be drawing just in normal use without any resistance on there. And we have a couple other steppers that you can check out depending on your project. The heat sinks that I used are listed on there. If you scroll down, there is a guide that Liz put together that gives you everything from an overview to the pinouts. So you can see here, listed on the back, it says this is 1, 4, 8, and 16. Doesn't it do 2? I think it does 2 as well. So this will also show you the pinout at the bottom there. So I'm running the board itself off of 3 volts from the Cutie Pie. Ground, direction, and step are the 2 digital pins coming off the Cutie Pie that will tell the thing what direction to go and if it should be stepping, and it just sends a pulse per step. And then these 3, MS1, 2, and 3 are what we can also wire up to GPIO in order to configure it for the different microsteps. Here we go. Here's a listing of the high and low settings for the microstepping. And then if you click on the CircuitPython in Python, this will give you a little wiring chart for the basic use and some example code to get it spinning, which is great. There's also an Arduino example, very similar. And then if you go to the downloads page, you can check out the CAD files for it, fabrication, print, schematic. You can also go to the datasheet. So here's Allegro DMOS microstepping driver with translator and overcurrent protection. This is the chip if you want to read up on the specs of it and go into a deeper dive on it. That'll show you how the schematic layout of the chip internally looks, as well as operating temperatures, voltages, currents, etc. So that's the chip that we've got there, broken out really nicely and conveniently with these nice big terminal block on here for wiring everything up. So it's very easy to set it up. All right, so let's see. Thank you again to Travis over in New Products for getting that taken care of, and we've got that pricing good till the end of the show. Then it'll go back up. So just throw them in your cart. You can get up to 10 of them. If you want to do a 3D printer kind of project, a carving robot, etching laser, you might pick up a few of these because every axis that you want to move on, X, Y, Z, up, down, turn a thing, they're each going to require their own to drive one stepper motor. Go for it. This is a great thing to pick up to use for that kind of project. All right. I think that's going to do it then. Let me know if there's any further questions over in the chats before we wrap things up. Let's see. Good? No? Good. All right. We are ready to go. So let's get out of here. This. What? Which? This. This right here. This is my product pick of the week this week. It is the A4988 stepper motor driver. For Adafruit Industries, I'm John Park. This has been JP's product pick of the week, and I'll see you next time. Bye-bye.